Hello and welcome, learners of Dr. B.R. Ambedkar Open University, education at your doorstep. Today we are going to discuss about sampling techniques, which is being offered to the MBA first year, first semester students. And the block is Sampling and Research Methodology, and the unit is 12 Principles of Sampling. Now let me straight away get into this fascinating world of sampling. Can you imagine that sampling actually helps us to predict a lot of things, including the diseases? So imagine that you are trying to predict a disease outbreaks, especially the epidemics, pandemics, all that, just by studying a few people or by a small group, and you are able to make estimates about the entire population. That's what it is, isn't it? And how does sampling going to help us make critical decision related to the limited data? We are always running short of the data, and that is where sampling will come to our rescue. So let's unpack and dive deep into the fascinating world of sampling. So how do hospitals actually predict trends from small data? As I told you, that data is always being limited. When you have data limited, so how are we going to make judgments and also going to predict about the outbreak of the diseases? Just by conducting survey on few patients, and we could save a lot of people or millions of people in the city so that they don't have to really get contracted with the deadly diseases. And that is where sampling will come to the rescue. And sampling techniques is basically going to make this possible. All the techniques that you see and come across are all happening because of the sampling techniques. And then lots of decisions that we take, they are not taken just randomly, but they are taken on the basis of data. So these are evidence-based medical research happening through data-driven techniques, and also providing lots of faster insights so that it helps us not just in taking care of the diseases but also for the prevention. And then not to forget that we will be able to save a lot of money. The cost saving is also related to sample. Let's look at what is sampling in research. Whenever we talk about research, this term you would generally come across. There is sample and there is also population. So what is sample? A sampling is nothing but selecting a subset of individuals from a population so that you estimate characteristics of the whole population. Looking at few things, you will be in a position to estimate and predict the whole population. And that is the beauty of sampling. And it actually helps us in reducing the time, because we don't have time to go around the whole population, look at all individuals in the population and conduct the survey. It is humanly difficult and also a time constraint. And what about the cost? Who's going to bear the cost of collecting such kind of minuscule data, especially going door by door, asking people what do they want, what are their taste, interests and hobbies, or maybe trying to understand the epidemics or pandemics. So in a way, it's also going to save a lot of money through sampling. And in the research studies, with the use of sampling, you will be in a position to provide great insights to the research community. So especially in the healthcare management, if you look at, sampling has come to a great extent and also great rescue to the researchers. Like, it's also very crucial in conducting surveys. So a lot of surveys are being conducted, be it patient satisfaction survey, be it the survey related to the flu or contagious diseases or vector-borne diseases. And that's why sampling will come to a great rescue. And not to forget, in the clinical trials, you will be in a position to look at the sampling surveys, and you can also monitor the diseases, the management of the disease is very important. All this is going to relate to the sampling techniques. Let's move on and look at the definitions of the sampling. If you precisely tell the definition of the sampling, I think there is no one definition as such. But in order to make things look quite easier, let us dive down into the sampling decision or the sampling definition. So the decisions related to the sample would generally come across through the definition. Like, let us look at. So sampling is the process. It's a step-by-step process of selecting a subset of individuals from a larger population. And also, what are we going to do with that subset? We are going to estimate the population, and we are going to estimate the characteristic of the whole population. Like how many people have contracted flu in Hyderabad city. So you may not be going door to door to take the sample, but you would just going to collect from few spots or few areas where the disease is prevalent, and you can make a lot of estimation. That's more about the education and also the educated guess in some sense. For example, let us look at, you are collecting the sample of 500 patients, whereas the hospital has some 50,000 patients, and this is also going to help you to assess the patient satisfaction. So what is this 500 and what is 50,000? 50,000 is the whole population, whereas 500 is nothing but the sample. I hope that makes a lot of sense to you. And why is sampling in healthcare? Well, sampling is used in almost all spheres of the knowledge of the world. Every sphere of life you may have sampling. But generally in healthcare, it's all the more important. Let us look at why it is important in the healthcare industry. In the healthcare industry, sampling allows researchers to study the subset of the population, and also you can draw a lot of inferences and conclusions about the population. In the previous example, we have seen that 500 patients were actually given the survey and the survey instrument, and through that conducting of the survey, you are in a position to understand the 50,000 patients. In the same way, it gives you newer insights, newer inferences, and lots of conclusion coming from sampling. Let's now look at through another ways, like sampling, of course, going to help you save a lot of time and also the cost. Now, let us look at through other practical usages of the sampling. Sampling basically enables you to take care of the data and data collection methods. Basically, it allows you to take care of the critical population. Like in large populations where you have millions of people, it is humanly difficult to go and collect from each and every patient. Hence, sample will come to your rescue. Like studying hypertension prevalence by sampling 1,000 patients in a city. So if you have collected the right proportion of the population, you are in a better position to not just take care of the treatment but also prevent the disease. That's the whole aspect as far as the healthcare management is concerned, and sampling plays a pivotal role in it. Let's move on and try to understand the sampling process. A sampling process is a step-by-step process because sampling is very scientific, and this is the science of understanding how to collect the data when you know or you may not know the population. So let us look at each one of the steps in greater detail. The first and the foremost step is to define the population. So what is your population? What is the population of city of Hyderabad? Or what about all the diabetic patients visiting a hospital? Do you have the data of all the diabetic patients? That means you're going to collect the diabetic patient's information from all the hospitals. That will constitute your population. So always define your population. Once you define your population, it would be easier for you to proceed to the next step. And what is the next step? The next step is to establish the sampling frame. The sampling frame is nothing but the patient registry, in this case of diabetes patients, right? Let us look at the third step. And we are logically moving from first step, understanding the population or defining the population, then also trying to establish the sampling frame. The third step in the entire process of sampling is the choosing the sampling technique. So there are various kinds of techniques that are available. So the objective of the study would also going to tell you about the technique. Like there are 4 in the probability sampling, like you have random sampling, stratified sampling, systematic sampling, and cluster. These are the different kinds of techniques that you're going to use it. In our subsequent lecture, or as we move along, we will be in a position to give you more details about these 4 techniques. But for the sake of information, let's look at only 4 of them as of now. Okay? Let's move on and look at the 4th step. What is the 4th step? The 4th step is nothing but calculating the sample size. How do you determine, how do you know what is the right sample? How do you make out that these number of people in the population would actually constitute or represent the whole population? And that is where you're going to use a simple formula. We will try and look that formula in a short while from now. And the last and the 5th step is nothing but collect data and analyze the results. So you are going to collect the data and you are also going to analyze it. So these are the 5 important steps that you're going to follow as far as sampling process is concerned. We spoke about the sample size. Let us look at the calculation formula. So in statistics, sampling has a wonderful formula. Let us look at this one. Small n equals to z square into p into 1 minus p, and then divided by, that is whole divided by e square. So I'm sure that you're following it. The formula looks quite simple. You may be wondering, where is this capital Z square come from? The capital Z square, or Z, generally is for the standardized score, as we call it, right? The standardized score. And in that, if you flip through the last pages of the standardized Z score, you will get 1.96. That is for 95% confidence interval, you're going to use the standardized Z score 1.96. Remember that, and it's quite easy. Let's move on. What is P in this formula? P here is nothing but the estimated proportion. For example, the disease prevalence here is 0.1. That is your P value. And then what is the next one? This small e equals to margin of error. And in this case, the margin of error is just 0.05. So it's very simple. You have in this formula Z square, P, and also E. Look at the same example problem to make things very clearer. Like if you insert n equals to 1.96 whole square into, just we are trying to insert the values in the formula. So here the P value given is nothing but 0.1 into, that is 1 minus P. So if you have 1 minus P, that is 1 minus 0.1 gives you 0.9, and whole divided by 0.05 square. So if you just compute it and calculate it, you will get 138 samples. This is the most important part of your calculation of the sample. So at least you require 138 patients to understand if you are conducting the patient's satisfaction survey. All right, and let's move on and look into the types of sampling. At the beginning of this lecture, I was telling you about there are different kinds of sampling techniques. In fact, the steps of sampling also we did mention at the beginning. Let us look at what are the different types of sampling techniques. We have two different kinds of sampling techniques. The first one is probability sampling and the other one is non-probability sampling. What do you mean by probability sampling? Probability sampling is nothing but every individual has a known chance of being selected. So you know that you can also be selected. Whereas in the other case, in a non-probability sampling, you have selection based on non-random criteria. So there is no set pattern, but there is a different distinct ways of the criteria. For example, in healthcare, you come across randomized controlled trials, popularly called as RCTs, and we have here convenience sampling in patient surveys. That's an example suitable for non-probability sampling. As far as these probability sampling is concerned, it is nothing but clinical trials. Clinical trials generally use the probability sampling more for accuracy and also brevity, precision, and so on. That is why we use the probability sampling in the clinical trials. Let us now look at the overview of sampling methods, right? We have now told you about probability and non-probability. So within the probability sampling, you have random sampling, you have stratified sampling, you also have cluster and systematic sampling. And as far as non-probability sampling is concerned, you have convenience sampling, judgmental sampling, and snowball sampling. This is the graphical representation of all the different sampling techniques that you have. Hope you are following that, and now let us go into the depth of each one of them. We will start with the random sampling, or popularly also called as simple random sampling. So what is this random sampling? A simple random sampling is nothing but it allows every individual an equal chance of being selected. So every individual in the population has an equal chance of being selected, and that is as simple as that. So it's more random, but it's also going to have the precision of being selected, and they have every probability of getting selected. So random sampling selects 100 patients from the hospital records for treatment efficacy. How are these patients being selected? Randomly, right? Out of 50,000 patients, you have selected 100 patients through simple random sampling. And there are lots of advantages and disadvantages for it. The advantages are quite simple because simple random sampling is going to help you to reduce the biases. As a researcher, you would certainly like to reduce the biases. You would not like to select people who are closer to you, people who are known to you, or ignore people who are unknown to you. And that is why it's important to look into the errors or the biases. So that's the first advantage. That means it reduces the biases. The biases could be part of the entire sampling technique, right? What are the disadvantages of the random sampling? Well, when you reduce a complete population list, or it requires basically the understanding and the whole, you have to define the population. Without the clear definition of the population, it's very difficult to have the random sampling. The more you define, the more you know the population, the better results you're going to get it through simple random sampling. Hope I'm clear about the first technique that you're going to use as part of the probability sampling. Let's look at the systematic sampling. What do you mean by systematic sampling? A systematic sampling is nothing but selecting every kth term or kth individual from a list. What is this kth individual, or who's this kth individual? For example, every 10th outpatient in a hospital queue survey. So if there are 100 patients who are coming, every 10th patient, like 10th, 20th, 30th, 40th, 50th, 60th, 70th, 80th, 90th and 100th. So every 10th patient who is coming to the hospital or standing in the queue that you are going to survey. This is a more systematic way of collecting the data, and that's why it's called systematic sampling. As far as its uses, merits and advantages are concerned. So this kind of sampling is basically easy to apply, like we have done it every 10th patient. It's so simple. Or every 5th patient, every 7th patient, every 20th patient, every 25th patient. Okay, now that we have learned about the advantages of systematic sampling, let us look at the limitations of the sampling. The limitations of the systematic sampling are plenty, like it also suffers from the periodicity bias. That means if the list order coincides with the sampling interval, then it can also suffer with lots of limitations. So this is the thing that you have to keep in mind as a researcher or someone who's trying to gather the data. Let's move on and look at the stratified sampling. As the word stratified is nothing but strata. It comes from the strata. So here the population divided into homogeneous subgroups, and that's where we call it strata, like we use in general local parlance, the strata of the society, right? Let us now look at the random sampling within the strata. So you can see within the strata you have random sampling. For example, stratifying by age. So you can classify them into different groups, like one of them is between 0 to 30 years, 31 to 60 years and 61 and above years. This is the strata and the groups or the subgroups that you have divided. And you are going to select the sample proportionately from each group, and that's the idea behind it. Do you get that? It's quite simple. You have divided them into subgroups and you're going to select it from these groups. And what are the different kinds of benefits and advantages that you're going to accrue? You're going to get lots of benefits. The first and the foremost benefit that you're going to get is to ensure that subgroup representation. Basically, for each group that you have selected, you need to represent that. That is the major impact of the strata or the stratified sampling. The other one is the application part of it. Where are you going to apply the stratified sampling? Mostly the objective of the study will tell you a lot about the stratified sampling. Like you are going to apply anything which is related to the age-specific diseases or the disease patterns that are emerging in these age groups. This is where you are going to apply it. And hence, stratification sampling or stratified sampling is quite useful in these groups. The last one of the probability sampling technique is the cluster sampling. Cluster sampling is nothing but population divided into clusters. What are clusters? Like cluster of hospitals. Hospital is a cluster, right? Okay, so randomly selecting clusters and study all individuals within these clusters. That's the idea behind it. So Let us say that you want to survey 5 hospitals out of 500 hospitals and collect the data from all the patients in those hospitals. That means you're trying to collect the data not from 100 hospitals, but you have clustered them into 5 hospitals and conducting survey or collecting the data from all the patients from the 5 hospitals. That's the beauty of cluster sampling. There are lots of advantages for the cluster sampling. One, of course, is that it's certainly going to save the cost, if not time. It might also require a lot of time, but it is going to save a lot of money or cost. Well, as far as disadvantage, or we may call it the limitation of the cluster sampling, is that it is less precise compared to the other techniques. Precision is another important issue with cluster sampling. So far, we have seen different kinds of sampling. Let us now understand through the case studies. There are umpteen number of case studies that are available to understand the different kinds of sampling techniques. The first case study that I want to bring to your notice is the flu prevalence survey. So if you want to know in a city or a major city like Hyderabad how the flu is being prevalent, you may like to conduct the survey. So what is the objective of the study? The objective of the study is to estimate. Whenever you use the term estimate, it is basically meaning that we are trying to understand the population through the sampling, right? So let us look at that. So the objective in the flu prevalence survey is to estimate the flu prevalence in a city. You can take any city for that matter. And what is the method that you are going to apply? Which method is more suitable? Which method is more natural as far as the sampling technique is concerned? In this case, because when we say it's a city, we are trying to make it a strata, right? That's why stratified sampling is being applied. Stratified sampling, trying to go to districts or by age groups in those districts. This is how you're going to conduct the method. And what is the outcome of this study? The outcome of the study is quite simple, which is data used to plan vaccination drives. Once you understand the population of the city, you can estimate the population of the city, and then you will be in a position to take the vaccination. You can run, or you can even have a vaccination campaign, and that's how it's being done. This is the first case study as far as the healthcare management is concerned. Let us look at the other case study. The other case study is about the patient satisfaction survey. There are lots of patients who come to the government and the private hospitals, and how do we take the satisfaction survey from the patients? So, in this case, the objective of the study is to measure hospital service satisfaction. That means that how many patients are really being satisfied with the services offered? What are the services being offered and patients' reaction to those services and their satisfaction level? So that's the objective. And what is the method? The method here in this case is random sampling. You may question, why are we not getting into cluster or other sampling? Because the objective of the study is very clear. We are trying to understand the satisfaction of the patient. Hence, simple random sampling is the method that is going to employed. Like, you may be able to take the survey of 5,000 patients instead of 50,000. So that's your appropriate sample. And what is the outcome of that survey? The outcome of the survey is quite clear. So let us say 78% of the patients felt the services offered by the hospital is satisfactory. They are satisfied with the services, and hence you can conclude that service improvement actions are taken. And if the numbers get reduced, so let us look at the results part. So 78% of the patients have said that the services are quite good, and they are also going to have a lots of satisfaction. and the hospital can actually learn a lot. They can either increase it from 78 to 90%, or maybe they can have 100%. I think most of the hospital would try their level best to satisfy the patients, and that's how the services are improved. So we can look at some of the sample size. For example, you have the data that is given to you, and you can even look at the slide which says the 95% confidence and 5% error and 20% prevalence. So if you insert the data into this formula, n equals to 1.96 whole square into 0.2 into 0.8 divided by 0.05 whole square, it gives you 246 samples needed. That's the way it is. You can even understand the sample through the charts, and you can also compare like the random sampling as well as systematic, stratified and cluster. You can see through the graphical representation, it's quite easy. What about the biases and the errors? Well, sampling techniques would certainly going to bring some biases. One of them is of course the random variations. The error is nothing but the random variation from the sample size, and whereas bias is nothing but systematic error occurring, for example, over-representing young patients. You're collecting data only from the young patients but not from the old patients. So that's the bias. So this is also another way to look at the stratified sampling. Random sampling example, of course, we all have seen, and it's quite easy. Systematic sampling, of course, all these are the examples of the cluster, systematic and other things. So you can even check the waiting time of the patient. If you want to reduce the waiting time of the patient, it is quite important to understand it. So the objective of the data or the objective of the study is to have the effectiveness of the new appointment scheduling system, so that the patients need not wait for a longer period. That's the whole idea behind it. Similarly, you can even have the monitoring hospital acquired infections as well. You can also do other kinds of surveys like analyzing the diabetes awareness programs. So you're trying to measure the effectiveness of awareness campaign, how the effectiveness of the awareness campaigns actually going to help you. So the sampling method here is the stratified sampling. So through the stratified regions and demographics, you're going to collect the data. That's as simple as that. So what are the different advantages of sampling? Well, practically it's quite beneficial. It's going to save the time. It's also going to have a lots of cost effectiveness, and it's easier, faster to collect the data, right? And it also enables you to understand the large population, which has always been difficult to conduct it. And through the exhaustive data collection, you may estimate as closer to the population as well. Well, everything is not so simple as it looks. So it also comes with bunch of different disadvantages of sampling. Sampling error is one disadvantage. There are also potential biases that can creep in when the researcher is conducting it, basically trying to have over-representation of something. And then the non-sampling error might happen through the measurement errors, right? So in summary, we can say that sampling is very essential for a feasible and for lots of research purposes. Without sampling, it's very difficult to imagine the research. And probability sampling is the best and offers the representative samples compared to the non-probability sampling. So non-probability sampling is generally useful for exploratory studies where it is just beginning, you don't know the phenomena or you don't have the understanding of the concepts. That's where you're going to use the non-probability sampling. Like we had the convenience sampling, judgmental sampling and the snowball sampling. And of course there are ethical issues as well. So what are the ethical issues? You have to keep in mind as a researcher or as a scholar that unbiased sampling, repeat, There are some ethical issues that you have to keep in mind as far as sampling is concerned. You have to be very unbiased. Unbiased sampling ensures valid generalizable results. That is the hallmark of any scientific study. Reliability, validity, and generalizability. So with that, we come to the end of this sampling technique lessons. Hope you enjoyed it. We look forward to your company again. Until then, it's goodbye from the studios of Dr. B.R. Ambedkar Open University.